friends, my name is Sanjeev Kumar. I am security corporate trainer and consultant for around 10 years now, and I deliver trainings on several products like Palo Alto, Checkpoint, Fortinet, F5 and Wireshark. Today I am going to discuss about the different kind of firewall that we have. So before delaying, let's begin with the firewall. So if we have to define what the firewall is, friends, firewall may be a software or a device that could allow or drop traffic based upon rules created by administrators. So it can be a firewall simply device that is protecting a network, and depending upon the rules created in the firewall by administrators, traffic can be allowed or denied. This may be the simple definition of firewall. Now we need to know the generations of firewall, how firewall evolved. So the first kind of firewall that we have seen is packet filter firewall. So first firewall is packet filter firewall. This packet filter firewall was a very old firewall. We are also using nowadays, but the use is very limited. So to understand packet filter firewall, we should consider the parameters that packet filter firewall use to allow or block the traffic. So for controlling the traffic, it uses few parameters like source IP, destination IP, source port, destination port, and protocol. So these 5 parameters are used to control the traffic. So how it goes, please try to understand the packet filtering firewall functionality, because once you know the problem in this packet filter firewall, then you will be able to understand the next generation of firewall. So let's try to understand what was the problem in packet filter firewall. So as I told you that there are several parameters here like source, destination, service, and action. A general firewall has these kind of parameters. Now, if you have to allow a traffic, you have to create a rule. And by considering this network as 192.168.1.0 network, if I want these network people to access internet, I need to create a rule, because by default a firewall is a blocking device. It does not allow anything by default. So let's create a rule. So my rule has source as 192.168.1.0. My destination, because I want to access internet, so destination is any. Service, because I know internet access depends upon HTTP, HTTPS, and DNS. So the services, and action is allowed. So I have written a rule, and with the help of this rule, the packet from these network, they can easily pass through the firewall. But the problem is not about passing the traffic. The problem is about how the traffic will come back. So as the traffic is about to come back here, source and destination got changed. And due to this change, there is no rule here. Uh, there is no rule in the rule table that could reversely allow the traffic. So the traffic will be blocked here. And for these users, the traffic is like the traffic has not moved through the firewall. The people will say that I have not accessed the services. For them, there may be firewall that is not letting the traffic go. So the problem will remain be there in packet filtering firewall. How can we solve it? We can solve by writing a reverse rule, and by writing reverse rule we can allow it. So I'm writing a reverse rule here. So destination becomes my source, source becomes my destination, and services remains the same, HTTP, HTTPS, and DNS, and action is allow. Now if you see here, by writing the rule I'm able to access the traffic come back. So users are happy because they are able to access their internet access. They are getting the internet access. But the problem is this rule. You can see here this rule, the source is any and destination is this network and these services, and action is allowed. It means anybody who is outside at the internet, the malicious user can enter to this network by using these services. And we do not want this thing. And this is the problem for packet filter firewall. How can we control this problem? We can control this problem by two ways. First, we can remove this rule. If we remove this rule, then definitely packet will be dropped while coming back. It will be a problem. Second solution may be we should not put the network here or any here. We should go specific. We should mention specific host and specific address, specific services. But in that case, administrative overhead will be huge. Every time you have to create two rules for each communication. So if you have 10 users inside and all those 10 users want internet access, you have to create 20 rules for them, right? So both are not possible. Both the solutions are not viable here. So packet filter firewall were not able to handle this situation, and due to this, packet filter firewall failed. Now the solution of this problem was provided by a new kind of firewall, and that firewall technology was developed by Checkpoint, and they call it Stateful Firewall. So now I'm going to tell you the Stateful Firewall. Stateful Firewall. In Stateful Firewall, we have two kind of table. We have this table similar to packet filter firewall, and we call it rule table. And we also have another table, and we call it state table. Now, what is the magic of state table? Try to understand, please. So, what happens here? So, a packet start moving from internal network to outside, and the packet comes to the firewall. Firewall will check the rule. Rule exists. Firewall see the action. Action is allowed. As the packet is decided to be allowed, firewall does two activities. First, it let the packet go on, Second, it write two bidirectional rule in the state table, and the rule is specific. For example, the rule may be like this: source, destination, service, flag, um, sequence number, acknowledgement number, action. Okay, so these are the parameter in state table. There are many more parameters, but for general understanding, I'm just keeping it simple. So now let's suppose that 1.10 is trying to make a communication. So when the traffic comes to the firewall see the rule 1.10 belongs to the source and traffic is allowed. As the traffic is allowed, the session table is created. The session table is created. In the session table, we have source. And now source is 192.168.1.10. The specific one. Destination. Suppose the traffic is going to Yahoo. So the destination is Yahoo. Service, as you know, it is HTTPS. Flag, suppose it is a SYN flag. Sequence number may be something. Acknowledgement number may also be something. And it also writes a return rule like this: Yahoo 192.168.1.10. Service is same. Flag may be different. Sequence number will be different. Acknowledgement number will be different. Now what would happen is, now when this rule get created, this rule will help the return traffic and next packets. Okay, let's try to understand. So first packet is moving to firewall. Firewall check the rule table. According to rule table, the packet is allowed. At the same time, two rules got created. Now the packet which went has to come back. But this time, while it is coming back, it will use the state table, this entry, to come back. And there are further packet of the same session. When now they will strike the firewall will not entertain using rule table. The state table will be there. So state table now will be used to allow the traffic in both the direction. So in this way, first, administrative overhead is no more there. The problem that was there in packet filtering firewall. And also the session table or the state table entries got removed automatically. So the state table is generated and deleted automatically. So it is also not keeping resources overloaded. So this way, stateful filter firewall have removed the problem of packet filter firewall. But this stateful filter firewall also have a bigger problem. The problem here is that this stateful filter firewall is only checking the same parameters as of packet filter firewall. So how the problem will be here? Please understand that suppose a user on 1.10, 192.168.1.10 tries to access a service outside, and there is a malicious website. When the traffic is coming from malicious website, there is no way for this host to check the content, while the state table is there to help that connection to come back. So the problem here is when traffic goes to malicious website, because of the state table rule, the traffic can easily come back and the host will become infected. So we need a firewall that could perform layer 7 inspection. So till here, till stateful filter firewall, no firewall was able to inspect the data. In a packet, as you know, you have a data and you have a header. So packet filter firewall and stateful filter firewall, they only checking the header, not the data. While here, the problem, if exists in data, there is no protection. And to achieve this protection, we have moved to a new kind of firewall called application filter firewall. Application filter firewall. As the name suggests, it works on layer 7, and because it is working at layer 7 where the data get generated, this firewall is more close to the uh, the layer 7. This firewall is more close to the data. So any kind of uh, data level protection can be applied here. So an application filter firewall is the combination of packet filter firewall, a stateful table firewall, and also it has an additional engine for data inspection. Now, once you have the application filter firewall, you can verify what kind of data is coming through those ports, the services. So application filter firewall is a combination of packet filter firewall plus stateful firewall and plus data inspection. And due to this data inspection property, now you have capability to allow Facebook and deny Facebook chat. So these are the three kind of firewall. Now we have a different kind of firewall also. We call it session based firewall. We call it proxy firewall. So okay, let's try to understand a session based firewall. A session based firewall is truly a proxy. What proxy does is, there is a client and there is a server, and a session based firewall always create two parallel connections. So client connects to the proxy, and on the behalf of client, proxy initiate a session to server, and when server responds to proxy, the proxy forward that response to client. So the session based firewall plays man in the middle kind of role, and hence we say that this kind of firewall can act at any layer. They can work from layer 1 to layer 7. And here you have more chance of altering with the traffic, playing with traffic, and controlling the traffic. So friends, this was the brief introduction about the firewalls. and the generations of firewall. Thank you very much.